Hey, today we're going to be talking about histograms and line plots. These are just two more methods to display and analyze data. And histograms are something that you've probably seen before. You just didn't know they were called a histogram. A histogram is a type of a bar graph, but notice that the bars are touching, and we'll talk about why these bars touch as compared to the bars on a regular bar graph where they do not touch. Alright, so these are going to be some characteristics about histograms. It uses bars to display data, and histograms show equal intervals of data. The intervals are here. From here to here, here to here, here to here. Notice that they are the same size. If they were not the same size, then our display would be very misleading. But in order for it to be a true histogram, these intervals have to be equal. Alright, the bars themselves show the frequency of the intervals, or how often they're happening. That's what frequency is. And it also shows the shape of our data. Those were the vocab that we did at the beginning of the unit, talking about peak, gap, cluster, skew, asymmetrical, and symmetrical. We can see that from this type of display. But what it does not show, they don't show individual data values. Just like our box and whisker plot did not show individual data values. It just gave us the 5-number summary. Here, it's grouping them within an interval. Alright, so we're going to focus more on reading and interpreting histograms for this session. And I think you're going to see they're not as difficult as you might have thought. Alright, let's jump on in. It says, what interval has the greatest frequency? The greatest frequency. Well, the one that is the most, this is our frequency, the number of students, and this is the number of minutes that they spend on homework each day. So the interval, that would be like the peak, or the greatest frequency, is at 12 for 40 to 59 minutes. Okay? What is the range of each interval? Now be very careful. This is not calculating the range from a set of data where you do the greatest minus the least. How many numbers are contained within each of these sections? The fastest way to calculate this is to say from 0 to 19, the range itself is 19. But you have to count the 0 in there, so you add 1 to it. So each section has includes 20 data values. Okay? That one can be tricky, so make sure you pay attention to that. You don't just do 19 minus 0. You have to include the 0, and to do that, you have to, the short way is to subtract and add 1 back in. Okay? Alright. How many students spend 20 to 39 minutes on homework? So 20 to 39 is this interval. That would be 6 students. And it's important that you put the label, even if you abbreviate. Alright, the next question says, how many students spend 60 to 79 minutes on homework? So number of minutes is 60 to 79. That would also be 6 students. How many students were surveyed? Well, you can't just look at this and say, well, it was 18 or 16 or 14. This is just showing you a scale for the graph. We need to look at the individual pieces of our data, individual intervals of our data to determine the total number of students. So we have 4 for this one, 6 for this one, 12 for this one, and 6 for this one. So 10 plus 12 is 22, and 22 plus 6 is 28 students. All right, true or false? From the histogram, can you determine how many students spent 45 minutes doing homework? Well, if you look, 45 would be in here. And some people say, well, it's probably down here. You can't tell. This is just saying this many students spent between 40 and 59. We don't see exactly 45 on here. So that would be false. We cannot see that. From the histogram, can you determine how many students spent 40 or more minutes doing homework? Okay, 40 or more minutes doing homework. Can we do that? Well, we know this many spent 40 to 59, and this many spent 60 to 79, so yeah, we could determine that. All right, so now I've given you a method for making sure that you are looking for keywords in your questions using the histogram to answer those questions. I want you to pause the video and I want you to do these 4 and the one below. Come back when you're finished. Welcome back. Here are the answers for 1 through 4 and then the problem at the bottom. If you need to, pause the video. I've highlighted what was important in the questions. I've also given some explanations on the true-false. One thing I do want to point out to you is that you need to make sure you understand we can't see individual data points on a histogram because everything is contained, the frequency is within an interval. We don't know what numbers were in between the 0 to 19 here. We just know that from 0 to 19 that 4 would be the answer. We don't know if there were 4 zeros or 4 19s or anything in between. Okay, if you need to, pause it so you can fix your answers. We're going to now talk about some line plots. So we're going to start with the definition of a line plot. They're also called dot plots. It's a number line with an X or a dot to display the frequency of numerical data. Well, it has to be numerical data because there's a number line, okay? You've probably seen these. You may not have known what they were called, but they're called line and dot plots. This one is a dot because it has the dots. If it had X's instead of the dots, it would be a line plot. Okay? They display a lot of information. You can see the shape of the data. You can see the frequency of the data. And one thing that's different from the histogram is here, we can see the individual data values, where on a histogram here, remember, we could not see individual values. We just saw things in intervals. So let's take a look at how we can read these. How many students were surveyed? Well, be careful. You need to read carefully. These numbers represent the years, and it says the number of years students played a sport. So the dots represent our students. Okay, so to figure out how many students were surveyed, we've got to count all of our dots. So 1, 2, 3, 4, 5, 6, 7, 8 of those. 4, 2, 4, and 1. So 12, 14, 18, 19. There were 19 students surveyed. Is there a gap in the data? We're going back to our shape of data. So there is a gap. What two data values don't have any information there? It's empty or missing. So the gap is at 4 and 5, because it goes from 3 to 6. How many students played a sport for 3 years? Well, 3 years, you read up and you get 4 students. How many students never played a sport? So what would that be? What number would represent never playing a sport? And you're right. That would be 0, and 8 students said they had never played a sport. What is the greatest number of years that a student played a sport? The greatest number of years. Well, it's not talking about the greatest number of students. The greatest number of years would be here, and it doesn't matter that there's just one dot here. It's just telling you somebody played for 6 years. Is there a peak? Think of a mountain peak. What's the highest point? Yes, the peak is at 0. That's the highest one. How many students played a sport for more than 1 year? More than 1 year would include 2, 3, nothing here, and 6. So 2 plus 4 is 6, and 1 makes 7. Do we agree on that? I don't know. Let's look at that again. How many students played a sport for more than 1 year? Well, we have more than 1 year. Would be here, here, and here. So yes, 2 plus 4 is 6 plus 1 is 7 students. Okay? Because we can't include the 1. It says more than 1. True or false? On the dot plot, can you determine how many students play the sport for less than 3 years? Well, can we see what's less than 3 years? Well, less than 3 years would be 2, 1, and 0. So yes, we could. That would be true. All right. Now, so we've talked about using this type of display to look at the shape of data. We've looked at the frequency of the data. Now we're going to go back and pull in the measures of center and see if we can determine the measures of center using this type of display. Here it's asking us for the median number of years played per student. All right. So what we're going to need to do is we're going to need to list out our data from least to greatest. Some people show students how to find the median using the display and just marking off. I think that confuses people, so the safest route is just to list all of our data. So we're going to have 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. We have 4 ones. 1, 2, 3, 4. 2 twos. 4 threes. And a 6. Now, that's a lot of data. And we already figured out there was 19, so we know there will be 1 in the middle. If there's 1 in the middle, that leaves us 18. So it's probably 9 on each side. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's our median. So the median equals 1. All right, what would be the mode, the number that we see most often? Well, this display is much easier to determine that than looking at our list. Here, the peak in this case would be our mode. So the mode is 0 years. Oh, and I probably should put years here as well. All right, now the mean. Remember the mean, which could be represented by X bar, says that we need to find the sum of our data and then divide by the number of data values we have. So these numbers aren't too bad to, I would suggest, doing them in a cluster. So if we add 8 zeros, we still have a 0. So that would be 0 plus, well, if we have 4 ones, that would be 4. We have 2 twos, which is 4. We have 4 3s, so 4 times 3 is 12, and then we have a 6. By clustering those values, it leaves less room for careless mistakes. So when you add the 4, the 12, and the 6, you should get, let's see, 26. So that is our sum. And this is the tricky part. How many did we add to get that sum? Now don't use this. Remember, this is already clustered. So we already know the total number of people surveyed is 19. So there should be 19 numbers. And 26 divided by 19 is something crazy. 1.368, blah, 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 blah. And it doesn't repeat, so let's round that to the nearest tenth. So about 1.4 years would be the mean. And the reason it's so small, guys, is because we have 0, 1, 2, and 3, a big cluster there, and then 1, 6, and we have mainly 0, so it should be a very small amount. I always tell my students to double check if they get a weird answer to make sure that it makes sense, and this would be one of those cases. Alright, moving on. We want to explain how a histogram and dot plot are different. Alright, what do you think? What's coming to mind? Well, I think the biggest difference is that histograms show frequency within intervals, while dot plots, dot or line plots, either one, they're the same thing, show individual values. That's the biggest difference there, guys. Now, how are they similar? Okay, well, they both will show display. You can see how many total data amounts there are. So we're going to say they both display how many data points are in the set. We can't see the individual ones on both, but we can see how many total for both. We can determine highest, and lowest frequencies. We can determine and the shape of the distribution. And that's where we use peak, gap, clusters. We can see all of that from both. So that's how they're similar. Alrighty, so here we just have a set of data and another set of data, and we just are going to practice finding the measures of center. And then over here we're also going to find the measure of center with and without the outlier. just as practice to review. And then we're going to also use the displays to find the mean, median, and modes. Okay, since this is review, I am going to have you pause the video and come back when you're finished to check your work. Oh, welcome back. You're going to need to pause the video so that you can check all of these individual values. What I found out is a lot of times that we needed to round the directions and dollars around, but hopefully your teacher will tell you when you need to round. I rounded to the nearest tenth most times. This one I left alone, but because I wanted people to know it wasn't exactly 203. And the purpose of this question is to show you that the outlier in this data, that 4, really changes the mean a whole lot more than it changed the median. So that's why the median would be best to describe this data. Down here, these were like little trick questions. We can't determine any of these things from a histogram because we don't see the individual values. Hopefully, you've been refreshed on histograms and have explained line plots to you and have shown you how to analyze data and use the measures of center from that data set.